In the last video, we introduced what a spontaneous process was, as far as a process that will occur without any outside intervention. I just wanted to make note that a non-spontaneous process does not mean that it is a process that cannot occur. It just means that with the current conditions, that process will not occur. So you can use energy to make a non-spontaneous process occur, such that something like electroplating, for example, if you pass an electrical current through some ionized metals, you can actually force them to be plated onto a surface, but that would not spontaneously happen without some outside intervention. So I just wanted to clarify that as we move into our next discussion here about reversible and irreversible processes. So we see in this first image here what is defined as a reversible process. So this is a process where the system changes in a certain way that we can put it back into its original state by doing the exact reverse of whatever process occurred. So let's take a look at this example here. Our system is at a higher temperature than the surrounding. So temperature T is our reference temperature, and our system is T plus delta T, this change in temperature. And then that would imply that to reach an equilibrium, the system would pass some energy, some heat to the surroundings. And we can see that if we reverse that process exactly, we would call this a reversible process in that sense that we could return our system back to its original state. And again, we have to exactly reverse the process, and that's understood here by subtracting that same delta T from the system to reach that same original condition. So let's look at what an irreversible process might look like then. So an irreversible process cannot be undone by exactly reversing the change. So in this example here, we see a piston over here. So this is our piston. And we have a vacuum space over here. And then there's some gas in the blue shaded region here. And there's what's referred to as this movable partition. So this partition is separating the vacuum space from the gas here. And if we were to lift this partition, so now it's been removed, we see this nice even distribution. So the color is as even as it can be here. So that implies that all the gas is expanded to fill the container. And we can see that the expansion of gas, we're referring it to as an irreversible process here. There's no work done by this system. So the act of the molecules expanding to fill the container, no work was done. But if we were to say, I'm sorry, not replace the partition, but rather use the piston here to push all the gas to one side, and then we could maybe put down that partition and get back to our original state, like over here, but work would have to be done. So there's some work done on our system greater than 0, whereas over here, 0 work was done. So that's why we can say that this spontaneous process will be irreversible, as are all spontaneous processes in one direction. So if we're spontaneous, in this case, in the forward direction, so we'll just call this the forward to the right here, we would be non-spontaneous. So spontaneous this way, the reverse, we would say is non-spontaneous. So again, the rationalization for that is that we cannot exactly reverse this change to the system. And in this case specifically, we would have to do work when no work was done initially. So in the next video, we'll talk about the second law of thermodynamics.